This time suck, and in this video we are looking at the binomial series. So when n is not a positive integer, and that is what that notation there means, it means that the normal binomial theorem cannot be used. And for a recap on that, watch my binomial theorem video. So instead we have to use the binomial series. And the binomial series goes as when 1 plus x to the power of n is equal to 1 plus nx plus n times n minus 1 over 2 factorial x squared. And factorial would basically mean all the numbers, so this would be 1 times 2. And then 3 factorial here is 1 times 2 times 3, and so on. And then that's add n to the n minus 1, n minus 2 over 3 factorial x cubed, and then this is continues and continues and continues. But it's only valid for when the expression is in the range of validity, and that is when x is between minus 1 and 1. But this will all make more sense when we start looking at a question. And the first question we have here is the easy question out of the three we will be answering today. And it says work out the binomial expansion of 1 plus x to the minus 2, and we'll do it up to x squared. So in order to do this, we are going to have to just use this formula that we have here and what is given in the exam. So therefore, we're going to start off with the 1. 1 is there, and then we're going to do nx. So n is minus 2 here, and x is just x. So therefore it's going to be minus 2x. Then we have n, so that's going to be plus minus 2 because that's n, and then that's going to be times by n minus 1. So that's going to be times by minus 3, and that's all over 2 factorial, which is just 2 times 1, and that's equal to 2 x squared this is. And then that is going to be add, so we have n, so that's n is minus 2, times by minus 3, and then times by minus 4. That is over 3 factorial, that's 1 times 2 times 3, which is going to be 6, and that's going to be x cubed. Now all we need to do is simplify it, so therefore we're going to have 1 minus 2x plus 3x squared and we didn't actually have to do the x cubed here because it did say up to x squared, but we have done it, so that's going to mean that minus 2 times minus 3 times minus 4 is equal to minus 24 divided by 6 is equal to minus 4x cubed. And then this would be add so on. But normally it will ask you to either up to x squared or up to x cubed. So the next question we have here is a much harder example, as we have things like a 3 in here instead of a 1, which means that we're going to have to substitute a 3 out, and so on. But first of all, it's good to reorganize this to make it into a form that we're more comfortable with using. And because the denominator is 3 plus x squared, what we can do is we can put this as a numerator, but make it minus 2 and make it the reciprocal. So in order to do this, we can say that this is equal to 3 plus x squared to the minus 2, sorry. And that is how we can rearrange this to make it slightly easier. And we're going to do this to up to x squared. So first of all, we're going to have to try and take the 3 out so that we have a 1 in. And this is so it's in the range of validity. We always want this to be 1 plus x. That's really the idea what we're trying to get. And I will introduce a y in it as well to make it so it's just 1 plus y all the time, and then we substitute in at the end. So then this is going to be 3 times, then we take a 3 out, because obviously that is going to be, so we can get the 1 here. But then as we take in a 3 out, this will also be times by minus 2 to the power of minus 2. So that's going to be 3 to the power of minus 2, and then we're going to have 1 plus, And instead of an x, because it's going to be x over 3, we're just going to put a y in here. So y, and then that's going to be to minus 2. And then we can write where y is equal to 1/3 x. Just makes it slightly simpler as we are going through the steps if we just keep it as y, and then we can substitute the x back in at the end. So simplifying this further now, we've done the first few steps to make it less tricky. This can go to now 1/9, and then we're keeping this the same, so 1 plus y to the minus 2. And then we'll keep the 3 out, and then we're using our previous thing. So the first one is just a 1, but that's going to be times by a 9th. So therefore we're going to have 1/9. So nx would be in this minus 2y, and then we're going to obviously times minus 2y times by 1/9. So that's going to be minus 2/9 y. And then finally, we will be looking at the n to the n minus 1 over 2 factorial. So n in this is minus 2, then that's going to be times by minus 3. So then we've got 6 on the top over 2. So that's 3x squared. That's going to be 3y squared. Then times that by 1/9, and we're going to have plus 1/3 y squared. So again, a slightly tricky workings there, but once you have it, again, it's fairly easy. Then we're just going to multiply it all through the 3, and that's going to give us 1/3 minus 2/3 y plus y squared. Now this is where we can substitute back in the x, and we've got the x here, this is why we took it out, and this is where we can put it all back in to get our final answer. So this is therefore equal to 1/3, that stays the same as there is no y there, minus, and it's going to be 2/3 times by 1/3 x, and then that is going to be add 1/3 x, that's all squared. So therefore our final answer is going to be equal to 1/3 minus 2/9 x, and then plus 1/9 x squared. And we've got that answer from just rearranging things and making sure it's in the range. Obviously this would have more terms, but we only need to go up to x squared in the question. So the final question doesn't really look like a binomial expansion, but we can get it into one by a bit of cancelling and algebraic fractions. And in order to do this, we are going to have to take some common terms here, and then we're going to have to cancel. So first of all, we can take a 2 out of this, and that would be 2, and then it'll be 2 minus 3x. And on the bottom, we can take out a 2 minus 3x as well, and then a 2 plus 3x. This is the difference of two squares. Now you may be able to notice that in both the denominator and the numerator we have a 2 minus 3x. That means that they can cancel. So we end up with 2 over 2 plus 3x. And this can be equal, if you remember what we just did in the last question, this can be equal to 2 and then 2 plus 3x to the minus 1. So now we're just following the same steps that we did in the last question, And first of all, we're going to take out another 2 so that we have a 1 here. So this means that we've got a 2 here, and then this 2 is times by another 2, and then 1 plus. Again, we're going to use this y here, and then this is minus 1. Also remember the minus 1 here, because a 2 is also to the power of minus 1. Now, this is where y, it's important you write this for the ending, but y is equal to 3 over 2. So therefore, we're going to add another step of just this to make it 2 is times by 1/2, 1 plus y to the minus 1. And that's just slightly more simplified. So then we will solve using the formula, the 1 plus nx times by so on. And this will get it to 2 on the outside. And then we're going to have the 1. So that's just going to be 2 and then half, because it's going to be half times 1. The next is going to be the nx, so n is minus 1, x is 3, so that's going to be minus y, that would be minus 1/2 y. The next one is going to be minus 1 times by minus 2, which is 2 over 2, so that's going to be, again, that's going to be y squared, times by half, that's going to be add 1/2 y squared. So you may be able to notice now that all of this is just going to, the halves is just going to turn to 1. So therefore we have 1 minus y plus y squared. Then we're going to add this 3 over 2x here. So put that in, substitute that in for the y's. Therefore, we're going to get 1 minus 3 over 2x. And then 3 over 2x squared is just plus 9 over 4x squared. So there we are, that is the binomial series. We've dealt with some difficult examples in here. The most important thing to remember is it has to be 1 plus x, and we make this 1 plus y so it's easier to deal with, and that is the most important thing to remember, as you will get harder examples like this where you do need to implement that. So thank you for watching and see you soon. Bye.